Assalamualaikum warahmatullahi wabarakatuh. I bid to Dr. Muhammad Azim and also my fellow teammates. So for today, we are from Group F, going to present a gyroscope experiment of EMM3812 Mechanical Engineering Laboratory. So my name is Noorashikin Binti Zulariffin. I'm a metric number 197659. My other teammate is Muhammad Nur Iman Hakimi bin Rosmadi 198957. Nur Najihah binti Abdul Razak 198897. Rizki Jaya Munandar 199634. Next. Okay, so for the introduction, a gyroscope is a device for measuring or maintaining orientation based on the principle of angular momentum. So basically, angular momentum is defined as any rotating object given by the product of moments of inertia and also the angular velocity. So for the equation is L is equal to I omega. So gyroscope basically consists of a rotor mounted so that it can spin rapidly about an axis, which is self-free to alter in direction. Next. So rotor of the device that rotate at high speed will become the true gyroscope, which include two basic properties, which is rigidity and also precision. Rigidity is a spin axis of the gyro wheel that tends to remain in a fixed direction if no force applied. So for example, is the Earth rotate with the same tilt. So for the precision, the spin axis has a tendency to turn at the right angle to directions of an applied force. So for example, is the counter steering on motorbike. So rigidity and also the precision, it depends on the angular momentum. Next, I will give to Iman Hakimi.
Okay, as for the theoretical background, so it was suggested nearly a decade ago that a measurement of the position of the spin axis of the gyroscope moving through the gravitational field that would provide a test of the Einstein theory. So this is the formula that were derived by the Thomas, Geodic and mass current. You can see here. Here M, R and V are the mass, coordinate and velocity of the gyroscope respectively, and F are non-gravitational force existed on it. So M, I and W are the mass, moment of inertia and rotational angular velocity vector of the Earth respectively. So as for the Thomas precision, it is the special relativistic rather than a general relativistic effect. So as for the Geodic precision, it is the true gravitational effect. Its contribution when integrated over an orbital period was first performed by D. Sitter. So as for the mass current precision, it makes the gyroscope experiment uniquely interesting. So we pass to the Rizki.
So okay, so maybe we can see the video first. Okay, so as in the video, this is a experiment example for experiment number 2, which is having a mass dimension of cube mass, which is 0.8, and then the mass itself placed at the bottom, and also using a constant speed at 50 warp rotation, and also having an angle of 50 degrees. So for this experiment, the material apparatus that I use, which is the gyroscope itself, and also the plasticine that act as a mesh for this gyroscope. So how do I conduct the experiment? So for the first experiment, I choose the constant angle or fixed angle, which is a 50 degree. And also we already stated that we use 3 speed, which is low, medium, and high speed. And also we use a mass of 0.6, 0.8, and 1 cm. So after that, we can proceed the experiment by turning the gyroscope with respective angle. And for the second experiment, also we put a mesh so we can see the velocity for this gyroscope. Yeah, I think that's all for the procedure. The next part will be continued by my friend. Thank you.
Okay, so I will continue explaining about the result and calculation for this experiment. So basically this is the formula related for the calculation and also specification that needed to calculate later on. So the first one I put here is the precision angular velocity, which is omega p equal to rmg over moment of inertia times angular velocity of this. And then the second one is the angular velocity of this, calculated by number of winding divided with time taken that we have take. And after that, time is 2 pi. The next one is the density of the plasticine, which is the mass that we use through the experiment 2. And the next one is the specification of this involved, which is the diameter and also the mass. So basically that is what is needed for calculation later on. So next. So the next one is the table for experiment 1. Experiment 1 is the spin speed as explained by Rizki just now. We fix the angle 15 and then there will be 10, 15 and 20 numbers of winding, rope winding around the shaft, and then time taken is tabulated there, and also angular velocity and precision speed is calculated with the formula that I stated before. The next one. This is for experiment 2. Experiment 2, we have 3 different masses, which is explained by Rizki also. So we use the density and the volume that obtained to get the mass, and then we add the mass of this with the mass of the plasticine in and put all together in precision speed formula that I show in the first of my slide. And then we get the precision speed for experiment 2, and then we use number of winding by rope with 15 as a constant, also the angle of shaft 15 throughout the 3 experiment. The next one, last one experiment is the experiment 3, which is location mass around the shaft. Okay, we use the same number of winding, which is 15 also, and the angle of shaft is 15, and then the mass of processing we use the lightest one. And then the position is the bottom, middle, and top. So we repeat 3 times with a different location. So I think that's all for my part. Iman Hakimi will explain about the discussion for the result that we obtain. Yeah. Okay, sorry. This is the basically what being mentioned in the table, and then I convert to the graph, and then Iman Hakimi will proceed with the discussion. Sorry, my bad.
Okay, thank you, Najihah. So based on the experiment 1, for the spin speed, the angular velocity is a constant at the first two we have done, and then it increasing as the number of coil increase. As for the precision speed, it also constant, and then it decreasing, and then it increasing as the number of the winding of by the rope around the shaft is increased. So when the number of coil is 10 and 15, the angular velocity is 6.98 radian per second, and the precision speed we get the 108.11 radian per second. And also when the number of coil is 20, the angular velocity are increased to 8.79 radian per second, and the precision speed were decreased by the increasing of the number of coil, that is the 85.8. So for experiment 2, the precision speed is increasing slightly as the mass are added into the gyroscope are increasing. The precision speed are lowest when the 0.4104 of gram mass was added, which is the 108.53 radian per second. So lastly, the precision speed was the highest at the mass 1.9 gram, which is the 111.22 radian per second. As for the experiment 3, the time taken for the gyroscope is different for the different direction of the mass along the shaft. The location of the mesh at the bottom recorded the longest time taken, which is the 11.2 second, and the lowest was recorded at the top, which is the 8.3 second. So, however, due to the malfunction of the gyroscope, we get the gyroscope that is damaged. The overall result, however, have some error due to malfunction of the gyroscope, which is the malfunction at the center part of the gyroscope. So the accuracy of the experimental result are reduced by the malfunction. Okay, that's all from me. I think Noorashikin will continue.
Okay, so in conclusion, for our experiment, as the number of winding by rope around the shaft of the gyroscope, which is known also as the spin speed in experiment 1, is increased, the angular velocity of this is increased, while the precision speed is decreased. As in for experiment 2 and also experiment 3, both precision speed is decreased as the mass added into the gyroscope increase and as the location is located further away from the center of rotation respectively. So lastly, the experimental and theoretical result has a slight differences due to probable error occurs, which is defects on the gyroscope device used while conducting the experiment. Next. As for the references, we refer to 3 types of sources, which is articles, book, and also the lecture notes. Next. That's all from us. Thank you.